Okay, what I'm showing here is anomalous medical software research, real-time image modeling, and the purpose of this video is to demonstrate the link between changes in the temporomandibular joint and changes in the occlusion. This is a controversial area in dentistry where oftentimes it is felt that the temporomandibular joint plays no role in altering the bite relationship. On our model, I'm going to go ahead and remove the skin so that we can look into the deeper portions here. And then I'm going to first take a look at the model's right temporomandibular joint, and I'm going to go ahead and create a discal displacement on the right side. You can see that there's an immediate shift in the mandible. Now I'm going to go to the left side and we're going to do the same thing. Now with this shifting in the position of the disc, there is a change in the patient's occlusal relationship. So typically what will happen is the posterior teeth will be premature when the disc is dislocated, but there can be adaptation, and that adaptation of teeth many times will hide the defect that is going on inside the temporomandibular joint. So here I'm closing down and adapting the teeth. To help you understand this a little bit better, I'm going to go ahead and make the skull itself a little bit more translucent so that now we can look very precisely at the teeth themselves and at the temporomandibular joint. I'm going to go back and remodel this before those adaptive changes took place. Now the teeth are going to adapt through clenching force, and what that means that they're going to change in their position. Now at that particular magnification, that may not be readily seen or readily understood, so I'm going to go ahead and take the model and I'm going to blow it up to where we can actually look at the teeth a little bit better, and I'm going to go ahead and hit my adaptation, and you can appreciate the fact that teeth are moving and intruding, especially on the maxillary arch. And I'll take this back one more time to the non-adapted state, and then I'm going to take the occlusion and I'm going to really hone in on the apices of these particular teeth. So let's really take this into high magnification, and I'm going to go ahead and unadapt the dentition here. And then with adaptation you can see the intrusion going on in the molar apices. Let me take it back again. And then as we're adapting, I'll go ahead and hone out on this so that you can see the changes that are occurring. Again, non-adapted, and then the changes that are occurring with adaptation. Now in the model I can also demonstrate this in a different way. For example, this model is taking very precise measurement lines, and in fact if you look at some of these numbers, we are out here to 1/100 trillionth of a millimeter of accuracy in the positioning of the left mandibular condyle, and the right mandibular condyle offset is very, very similar. And in fact, as we make changes, for example, if I go back to the normal disc alignment, in particular you can look right here at left ramus height, which would be represented by this particular line. And as you watch the left ramus height, you can see that it's about 68.69, and with distortion of the right temporomandibular joint disc first, there is a change in vertical height of the left joint. Then with dislocation of the left disc, that vertical height distorts even further, here more than a millimeter. And then as we go through adaptation of the bite in the posterior, the ramus height stays relatively the same. I'm going to take this back to normal again, and now I'd like to draw your attention to the relationship from the tympanic fissure to the mesial contact point of the mandibular first molar. This would be left fossa to tooth number 19, and you can see here in the normal state left fossa to tooth number 19 is 85.74 millimeters, and as I distort the right temporomandibular joint disc, that number doesn't change very much. However, with distortion of the left temporomandibular joint disc, that number drops down to 84.79 millimeters. And then with more adaptation of the teeth, which I'm doing right now, the number is going back up to about 85. Now, another way of looking at this is to examine the anterior, and to demonstrate this, I'm going to go ahead and hide the teeth. And when you look very, very carefully here, you can see that there's a very faint blue line here in the anterior. And what this is the relative positioning, both vertically as well as horizontally, in the posture of the anterior teeth. So I'm going to add those back. And the first thing that we're going to look at here is going to be the vertical distance from tooth number 8 to tooth number 25, and when I go back to the normal state, this is about 0.3 millimeters. And as I dislocate the right temporomandibular joint disc, it's going up to 1.1 millimeter, distorting the left temporomandibular joint disc. That number is going up to almost 2 millimeters. And then when I go back to the adapted state, I'm bringing it back down to basically 0.1 millimeters. So I'm somewhat over adapted. So that relationship would also tend to change depending upon how much clenching a patient might do in the back end. So here we have carefully modeled subject software that shows that indeed there is a change in the occlusion with any kind of change at the level of the temporomandibular joint. This modeling software actually allows us in some of the areas to go out to 1/100 trillionth of a millimeter to measure the changes. Of course, these changes are actually much more gross than that, and you can see on the order of a half of a millimeter to several millimeters of changes in the system, again depending upon what happens at the level of the temporomandibular joint.